Hello, I'm Ian Lee, and this is problem 11 of chapter 15 of the physics textbook. Three charges are arranged as shown below. Find the magnitude and direction of the electrostatic force on the charge at the origin. So this is the charge at the origin, and let's just mark out our forces. Let's call this force, well, over here, force Y, because it's in the Y direction, and these are opposite charges, they're going to attract one another. And now let's take the force between these two particles, force X. And because these are like charges, they repel each other. So first, let's calculate force Y. So we use the electrostatic force equation, which is Ke Q1 Q2 or squared. And the charges are absolute values, so they're always positive. So Ke is a constant that's equal to 9 times 10 to the 9th. And first we look at 3 nanocoulombs, so that's 3 times 10 to the minus 9th coulombs. And then we take this one, which is 5 Nc, or 5 times 10 to the 9th coulombs. We divide that by 0.1 squared, that's 10 to the minus 2. What we're left with is 135 times 10 to the minus 7th. Or you just say 1.35 times 10 to the 5th newtons. Now we look at force X. Force X, we do the same thing. And now we basically look at our charges. So you got 9 times 10 to the 9th. This is 6 Nc, so that's 6 times 10 to the minus 9th coulombs. And this is 5 Nc, that's 5 times 10 to the minus 9th coulombs. And since this is 0.3, we do 9 times 10 to the minus 2. We can just cancel this out, and what we're left with is 30 times 10 to the minus 7th, or 30 times 10 to the 6th newtons. So now let's take the charge at the origin and basically construct a diagram from this. So first we have our charge forces. This is 3 times 10 to the minus 6, and this is 1.35 times 10 to the 5th. We just try to construct this into a square, and we draw the diagonal. This is what we want to figure out. So first, we do the Pythagorean theorem, which is 1.35 times 10 to the 5th squared plus 3 times 10 to the minus 6th squared. Take the square root of that, and we get approximately 1.38 times 10 to the minus 5th newtons. Now to find this, we need to do tangent theta y over x. So all I do is just we take force y, which is approximately 1.35 times 10 to the minus 5th, and then we take force x, which is approximately 8 times 10 to the 6th. If we divide this up, it's exactly 4.5. And now we find the arctangent of this one, and theta is approximately equal to 77 degrees. And remember, this is 77 degrees below the minus x-axis. So our final answer is 1.3 times 10 to the minus 5th newtons at 77 degrees below the negative x-axis. So the magnitude and direction of the electrostatic force on the charge at the origin is 1.3 times 10 to the 5th newtons at 77 degrees below the negative x-axis.